Problem number 6. A sandwich store charges a $10 delivery fee and $4.50 for each sandwich. What is the total cost, sandwiches and delivery charge, if an office orders 6 sandwiches? First, we're going to write the equation of a linear function, which we know as y equals mx plus b. And we know this is a linear function because for every additional sandwich, the total cost increases by $4.50. So this is an additive constant. And so we are going to set the slope as $4.50. We'll keep the x. And we're going to add the delivery fee of $10 as our y-intercept because even when we order 0 sandwiches, there's going to be a delivery fee, let's say, right? So it's not really realistic because if you're placing 0 orders, there shouldn't be a delivery charge. But let's just say they charge you $10 if you order 0 sandwiches. Okay, so we are going to find out the total cost, which is y. I'm going to list y as total cost if we order 6 sandwiches for the office. And we're just going to plug in x as 6. So when we plug in the x as 6 and we work with this equation, we're going to see that we're going to get an answer of $4.50 times 6, which is 27, plus 10, and gives us a total cost of $37. That includes now the delivery fee, keeping in mind that it's $4.50 per sandwich. So it's going to be $37 to order 6 sandwiches. I'm going to write the total cost is $37. In parentheses, I'm going to write including the delivery fee. To order 6 sandwiches. Part B, what is the total cost for X sandwiches? Now, we are just going to write the equation for this linear function or equation. And that's the answer. Y equals 4.50x plus 10 for the total cost for X sandwiches. So we don't know the cost of however many sandwiches there are. We will replace the 6 sandwiches now with just X because we don't know how many sandwiches. Now we're going to graph the total cost of sandwiches and delivery based on number of sandwiches ordered. And we're graphing this equation. So we're going to start with, let's just label this maybe starting with 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. We have a 20 here. And we're going to label the X in ones. All the way up to 10. So we don't have a lot of room here, but the x-axis is going to be labeled as number of sandwiches. I'm going to squeeze it on the bottom here, number of sandwiches. And our y can be our total cost. All right, and we know this is going to be a positive slope because as the number of sandwiches increase, the total cost also increases. So this is a direct relationship. And we're going to first start by plotting our y-intercept of 10. Now it goes up by $4.50 for every one increase in x. So our slope is $4.50 or 4.5. And so I'm really going to increase by 4.5. Well, 10 plus 4.5 is 14.5. And so if this middle line is 15 here, 14.5 is right in the middle of 14 and 15. Do you agree? It's right here. And so I am going to plot my point right over here. For every one increase in sandwiches, the total cost increases by 4.5. So keep in mind here that 4.5 or 4.50 can be written with a 1 underneath, which is why we are running 1. So this is rising 4.5 and running 1. And I will keep going. So from 14.5, if I add another 4.5, we are going to get 19. And so I'm going to plot my second point here. I'm going to go up to 19, which is between 18 and 20. So right over here. And I'm going to plot my point right there. And so this is going to be the line, which I'm going to put an arrow on because it continues, right? You can order more sandwiches and you can see that the total cost is going to be also increasing. Now, your graph could look different from mine just because of the intervals that you use, which is going to be totally fine.